In this video, we have a rectangle inscribed in a semicircle of radius 1, and we want to express the area of the rectangle as a function of the angle theta seen here in the diagram, or another way to say it, in terms of theta. So let's look at the diagram. So notice we have one side of the rectangle labeled as y, and keep in mind that this is a perpendicular here. All the angles of a rectangle are right angles. So these are right angles here. So we have one right triangle here. This side, the hypotenuse of the right triangle here in red, that's 1, because it goes from, because the distance labeled here is from this point here to the circle over here, it's labeled as 1 here. You know that's the radius. So from this point to this circle again, that's 1. I could construct another hypotenuse here, and this side of the triangle here and this side over here would be the same measure. Opposite sides of a rectangle are congruent. They have one common angle, and because of the symmetry, this is x here, these are congruent triangles. So I can label this as x also. So I know that the area of a rectangle is the length times the width. So from this diagram then, one length is y, and the other one, this is x then by the, again, these triangles here and here, those are actually similar triangles. They're actually congruent. So we know that this is x, this has to be x also. So we can set this up then. Just say area then is equal to whichever one we want to call the length here, doesn't matter. So this is 2x and that's y, so I'm just going to put it as 2x, and the other side is y. And now we simply need to express the x and the y in terms of theta. So looking at the triangle here with hypotenuse here in red, I can just say that the sine of theta is the opposite over the hypotenuse. So the opposite side is labeled as y, and the hypotenuse is 1, so that's y over 1. It's just going to give you y. In the same way, I can look at the cosine of that same angle, theta, and that's the adjacent side, which in this case is x over the hypotenuse, which is 1. It's x over 1, but that's still x. So then the area in terms as a function of theta would be 2. Just make the substitution then. And then for x, we got cosine theta. So this will be cosine theta. The y is sine theta. So the area of the inscribed rectangle in terms of angle theta is given by this formula right here, this function right here. A equals to 2 cosine theta, sine theta. More to come on this particular problem. We can call this one part 1. Very short, and we'll pick it up next time. Thanks for watching. See you next time.